Hello everyone, my name is Anuradha Saharan. I'm here discussing about mm, applying machine learning and Python based on dashboard to enhance early prediction of food waste in sustainable agriculture. This research focuses on applying machine learning techniques alongside Python based dashboard to improve the early prediction of food waste in sustainable agriculture. The study was conducted as a part of my master's in data science at Cardiff Metropolitan University. The motivation behind this research stems from the increasing global concerns around food waste, which not only leads to economic losses but also contributed significantly to environmental degradations. Now let's move on to next slide, global challenges. Food waste is a critical global issue with significant impact across environmental, economic, and social dimensions. As shown in this slide, large amount of food are lost between 2018 and 2024 across production, storage, and distribution stages. This result in resources depletion including waste land, water and energy alongside increased greenhouse gas emissions, particularly methane and from landfills. Next, I had like to discuss about aims and objectives. The main aim of this research is to develop machine learning models and an interactive dashboard to predict food waste and support early intervention strategies. This aim is structured into four key objectives. The, the first objective is to design and implement machine learning models capable of prediction food waste based on agriculture and demographic data. The second objective focus on developing a Python-based dashboard using Light, which allows user to interact with data and prediction in real time. The third objective is to evaluate the performance of the module using metrics such as R square, MA, RAM's accuracy, and F1 score to access predictive reliability. Finally, the fourth objective is to assess how early prediction can contribute to reducing food waste and improving sustainability practices. Moving forward, uh, let's next topic is a problem and hypothesis. The key problem addressed in this research is that a food waste forecasting remains underdeveloped. Existing system really heavy on a historical reporting rather than predictive modeling, which limits proactive interventions. Additionally, even when predictive model exists, they are rarely integrated into user-friendly systems, making them inaccessible to non-technical users. Next, I had like to describe about literature review. The literature highlights that food waste is a systematic issue occurring across all stages of the supply chain, including production, storage, transport, and consumptions. Existing research shows that machine learning is widely applied in agriculture, particularly for crop field predictions and disease detections. Now let's move on to methodology. This study adopts a positivist research philosophies focusing on objective data driven analysis. A quantitative approach is used specifically predictive modeling to analyze patterns in a food waste. Let's take a look at a model selection. This study uses both regressions and a classifications model to address different aspects of food waste predictions. Regressive models are used to predict the quantity of waste in a tons, while classifications models are used to identify high risk scenarios. Next, I had like to discuss about implementations and dashboards. The system follow a three-layer architecture. architectures consisting of the data layer, machine learning layer, and dashboard layer. The data layer handles data loading, cleaning, and processing. Machine learning layer performs feature engineering, model training, and evaluations. Now let's move on to finding data insights. The analysis of the data set reveals several important insights between 2018 and 2024. A total of 125.3 million tons of food waste was recorded, with an estimated economic loss of 1.25 dollar billions on average. Each contributed approximately 109.5 kilograms of waste per year. Moving forward on model performance, the model evaluation results indicate that predictive performance is a limited. The best regressive model, linear regressive, achieved an R square score of approximately 0.03, suggesting that the model explained very little variances in the data. The random forest model achieved a mean absolutely error of around 13,000 tons. Next, I had like to discuss about risk assessment. The risk assessment analysis identifies key high risk countries including Turkey, Canada, Spain, Germany, and Mexico. These regions require immediate interventions due to high level of food waste. Let's go on the next slide discussions. The finding partially support the research hypothesis. While machine learning models demonstrate limited predictive accuracy, they successfully identify trends and risk patterns. More importantly, the integration with an interactive dashboard significantly enhanced decision making. Let's take on a second next slide. Recommendations. Based on the findings, several recommendations are proposed. In the short term, stakeholders should adopt data-driven decision support system to enable proactive waste management. Awareness campaigning should also be targeted at high risk countries and sectors. Let I have I had like to discuss about conclusion. In conclusion, the research demonstrates that while machine learning models alone may have a limited predictive accuracy, their integrated with interactive dashboard provide significant values in supporting early decision making. The study highlights the importance of combining analytic tools with user friendly interface to bridge the gap between data science and partial applications. And ultimately, this approach contributed to make more suitable agriculture practices by enabling early interventions and research optimizing. That's all. Thank you so much.